Okay, so last week we talked about identifying congruent triangles by side angle side, right? So you had to have two sides with the included angle, the angle between them, to prove congruence. So today we're talking about two other ways, which would be side, 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 which that's one of the easiest ones. If all three sides are congruent to all three sides of another, they're the same, okay? And then HL stands for hypotenuse leg, okay? So we're going to go through those two examples, look at some different problems on if we can say that they're congruent or not. We'll go from there, okay? All right, so first one is side, side, side congruent. Excuse me, congruence. Says if three sides of one triangle are congruent to three sides of another triangle, then the two triangles have to be congruent. So, on this first example, somebody tell me some sides we know that are congruent to each other.
B, C, and D, F.
Okay, we know those two are congruent because they're both marked with two lines. What else? Somebody else.
B, A, E, D.
B, A, and E, D. Just as a reminder, you could also say A, B, and D, E, right? And what's the last pair?
A, C, and D.
AC congruent to DF. Good. So, since all three sides are the same, we can say triangle ABC is congruent to what triangle?
D, E, F.
DEF. Good. Now remember, this one was kind of easy because they're listed the same way, right? ABC is listed the exact same way as DEF, right? Or you can think I went through a side with one mark, then through the side with two, so through one, through two to name triangle DEF. Okay? Simple enough? Truthfully, I think side, side, side is the easiest one because you guys can quickly identify if all sides are the same. Okay? All right, the last one we're talking about today, or the other one, is hypotenuse leg. What type of triangle would you have to use hypotenuse?
Right.
A right triangle every time. Okay, where's the hypotenuse located?
The right angle.
Say again.
Oh, the right angle.
Where from the right angle?
The top.
Adjacent to, across from, like we have to know exactly where it's at. Because there's one specific side here that's the hypotenuse.
Adjacent.
Adjacent means next to. So both of these would be adjacent, so how would you know then which one's the hypotenuse?
Oh.
So it has to be where?
Across.
Across. Always across from the right angle is your hypotenuse. Does anyone remember what we call the other two sides of our triangle?
Adjacent.
No. Who said that over there? Somebody, legs, yes. Okay, so right triangles have two legs which connect to form a right angle, and then the hypotenuse is directly across from the right angle. Okay, so it says if the hypotenuse and a leg of one triangle are congruent to the hypotenuse and leg of another triangle, then the triangles are congruent. Now, here's where people tend to have a little bit of trouble. Don't write this down, but I'm just going to show you. Let's say it didn't give you this mark here, but it gave you this one. I have a lot of people that say, oh, it's a right angle, excuse me, and it has two sides the same, so it must be hypotenuse leg. Why does that not work here? Because it's not across from the right angle. Okay, so you have to be careful when you're looking at a right triangle. The first thing I would look for is across from the right angle. If those two sides are the same, then you probably have that if you have an extra side. Okay, so somebody tell me, What sides do we know are congruent on these two triangles?
AB and ZX.
Good. AB is congruent to ZX. Somebody else tell me the other one.
YX.
So, since I have a hypotenuse congruent to itself and the other congruent to itself, then I can say triangle ABC is congruent to what triangle? ZXY. Good. Right. Again, just as one reminder, I went through one side, through two sides. So I go through one, through two. Okay? Questions on either of those? All right, back page. We're just going to look through a few examples. Okay, now, before we start this, here's what I want you to do. So it asks you, can you use side, 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 angle, side, which we talked about last week, or hypotenuse leg to prove that triangles are congruent? Now, on these 6 examples, are there things that are congruent that are not marked?
Yeah.
Tell me what types of things.
The line in the middle.
Yeah.
What's that called?
Bisection?
Adjacent. No.
You don't even have to give me the exact name, just like this right here. Those two triangles do what?
Share line.
Say it again.
Share line.
Yeah, they share that side. So we need to mark shared sides. And then what other thing do we see on here that's not marked that we know is congruent?
Vertical angles.
Vertical angles. Good. Okay, so I'm going to give you a second. I want you to go through and mark any shared sides and vertical angles that you see on examples 1 through 6. Okay, and then I want somebody to tell me anything that you marked. Tell me what example.
Example 1.
What'd you mark?
Number 9.
Okay, with how many?
3.
Okay, somebody else?
The second one in the middle with 2.
Good. Shared side. Anything on 3? No. 4?
Yeah.
Where?
Shared side.
Shared side.
2.
What about on 5?
Vertical angle.
Wait. 3.
Okay, and 6?
3 on the 6.
Good. Okay, now we're going to go back. It gives us 3 possible choices. What are our 3 choices we can choose from?
Side, side, side.
Side angle side. Hypotenuse line.
Good. Okay, so on example 1, does it fall under any of those 3? Side, 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 right? We have all 3 sides on both triangles. So side, side, side. Good.
That's how we split.
Yep.
Hypotenuse leg.
Okay. Why can I say hypotenuse leg on number 2? What's the first thing you see?
Across.
We see a right angle, which is the important thing. And then across from our right angle is the hypotenuse on both. And then what else do you have?
One side.
One leg. Good. Okay. What about on example 3?
Side angle side.
Because the angle is located where?
On the leg.
Between the 2 legs, yes, or just between the 2 sides that are congruent. Why can you not say hypotenuse leg here?
It's not across.
Not across. It doesn't include the hypotenuse, right? It would have to include that side. Okay? Everybody okay with those 3? All right. What about number 4?
Triangle side.
Do we know, though, that those 2 angles are congruent?
No.
We do? Why?
The shared line.
We know that the side is congruent.
The line.
Is it not possible that one side could be 91 and the other side could be 89?
I guess so.
And they, still look like they're congruent?
Yeah.
Yeah. And it hasn't given us any information to tell us that they're congruent, so we can't use either one of those, okay? So here we would just say no or not enough information. Okay, what about example 5? Do we have all three sides?
Yeah.
South side, side.
We have all three sides here?
No, there's angles.
No, we have all three angles. That's different. Do we have side, angle, side?
No.
Do we have hypotenuse, leg?
No.
So none of the above. Okay, what about our last one?
Side, side, side.
Good. Okay. All right. Last section asks you to determine what additional information is needed to prove the triangle is congruent. Okay, so here we're going to prove side, side, side. What does it tell us for sure?
AB is congruent to AB.
It tells us AB is congruent to AD, so I can mark those two sides with 1. What else do we know for sure? Yeah, the shared line is congruent to itself. So for side, 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 what other piece of information would they have to tell us?
BC is congruent to.
Good. Yeah, they would have to tell us that last set of sides is congruent to each other. Okay? All right. Now, the second one's a little bit trickier. Okay? It asks us to prove by side, angle, side, and what's the only piece of information it tells us?
JK.
All right?
And the shared line.
And we know the shared line. Okay? Now, there are a couple ways to do this, okay? But does anyone remember when we talked about these parallel lines, what other piece of information we know? There is something else here we know for sure. Think back to when we did parallel lines that were cut by a transversal.
Like, it can like fold.
Say it.
Alternate and
Good. Anytime, you guys, we see parallel lines with a line cut through them, we should think to look for alternate. Sorry, I put that one on the wrong side. Hold on. That should be here. Okay. So, if I want to use side, angle, side, can anyone tell me now what side I need left to prove that?
And
Angle
okay.
J and angle L.
It's
Well, I already know this angle, and I already know this side.
it's JM and okay.
Can you not,
I disagree.
can you take K and
Why?
because there's an angle with the shared line. Yeah, I just
Because, remember, if I know this side, right? And then I have this angle, so then it has to be the side with the angle included between. Okay? So it has to be JK and it has to be ML. Now, could you have used this angle over here and this one? Yes, it doesn't matter which one you choose. That's just the one we went with on this one. Okay?
Can you not put like angle J equals 90? Then you can not. Oh wait, no, never mind. I was thinking of
Hypotenuse. Yeah. Okay. All right, last one. We're proving by hypotenuse leg. It tells you C is the midpoint of DB. So if C is the midpoint of this line, what information does that tell us about these parts?
They're the same.
They're congruent, right? A midpoint always cuts something into two congruent parts. And then it says that AE, this line here, is what? What does this symbol mean? Perpendicular to DB. Well, what does that tell us about? What does perpendicular mean? Right angle. Good, Caden. So it tells us we have right angle here. So if I was going to prove hypotenuse leg, what's the last piece of information I would need? Say it again, Josh. Good. AB is congruent to DE. Okay? How we feel about this part? Getting better? Been better. Oh. Okay.
Sign on these?